Hello, today we are going to learn about graphing polynomials. So when we graph polynomials, there are a few different characteristics we like to look for. One of them is called end behavior, another is called turning points, another is called roots, and then another one is called multiplicity. So we're going to be looking at those four different things today. The first one we're going to look at is end behavior. So just like what the name suggests, end behavior of a polynomial is saying if I go to like positive infinity in one direction or negative infinity in one direction, what is my graph doing? Is it going up for forever? Is it going down for forever? What direction is it pointing? Essentially is what it's saying. So there are some patterns that we can learn when it comes to end behavior based on the way the polynomial is written. So when we are looking at our polynomials, what we're going to do first is we're going to find the first leading term. So we want to find the term with the highest power. So that will usually be, if it's in descending order, it will be the first term. And we want to look at that coefficient, that number in the front of the variable. We want to look and see if it's a positive or a negative number. So the actual number value doesn't really matter, but we're just looking to see if it's positive or if it's negative. And then we also like to look at the exponent. Is that exponent an even degree or an odd degree? Based on that, your polynomial is going to do different things. So the first thing I look for usually is the power. So if that power is an even number, 2, 4, 6, 8, etc., then your end behavior on your graphs is going to go in the same direction on both ends. So both ends are either going to go up and up, or they're going to go down and down. If it's an odd degree, then your ends are going to go in opposite directions. So one will go down versus up, or will go up and then down. So the degree, if it's even or odd, is going to tell you that part. And then, so let's say you have an even degree on your polynomial. You know it's either going to go both up or both down. So then to determine if it's going up or down, that is based on that coefficient, if it's a positive number or a negative number. So if that number in front is a positive number, then they're going to go up on both ends. If it's negative, then they're going to go down on both ends. And then let's say you have an odd exponent. So like in this example, it's an x to the power of 5. To know if it's going down to up or up to down is again on if that coefficient is a positive number versus a negative number. So if it's a positive number and an odd exponent, then it's going to start going down on the left side to going up on the right. And then on the flip side of that, if it's a negative coefficient and an odd exponent, you're going to start going up on the left, and then you're going to go down to the right. So I think these two are the harder ones to tell apart just because the shapes are so similar. So my little trick for this is think of it kind of as a slope. When you guys first learned slope back in like middle school, if you had a positive slope, then you knew that your slope went up from left to right. But if you had a negative slope, your graph went down from left to right. So that kind of gives you the overall shape that if I'm going from left to right, this graph is going up in the positive direction. But if I'm going from left to right still, I'm going down in this one. So that's kind of my trick to keep or to tell these two apart, is again kind of think of it as a slope. We always go from left to right, same direction we read. On this direction I'm going up, so I'm going positive, and on this direction I'm going down. So that is your end behavior. Let's just recap it again really quick. So if you have an even degree, you're either going to be going up, up, or down, down. And you tell that by if the coefficient is positive, you go up, up. If it's negative, you're going to go down, down on both ends. And then if it's an odd degree, with a positive coefficient, you're going to be going up from left to right, so down and then up. If you have a negative coefficient, you're going to be going down in the negative direction for your slope. So you're going to start going the top, and then head down to the right. So that is end behavior. One of the other characteristics we talk about when we look at graphing polynomials is something called turning points. Again, it's a pretty straightforward name. We're not very creative in math. So turning points is literally when your function turns, or turns directions. So a turning point of a function is a point where the graph of the function changes from sloping up to sloping down, or the opposite, you could be going sloping down to sloping up. So it's literally where your graph is going to be turning. So here would be a turning point, and here would be a turning point. So pretty straightforward. So to tell how many turning points you have without actually seeing a picture of the graph, you can tell this just based off of the formula. So if you look at your polynomial, what you're going to do to find the number of turning points is you're going to subtract 1 from the highest degree of your polynomial. So let's say I have an x to the 5th. That means I'm going to take that degree of 5, we just subtract 1 from it, so that's going to have 4 turns. So I don't even actually need to see the picture of the graph. I can just know the equation, and I will be able to tell how many turning points it has. So here's another example. If I have this polynomial, 3x to the 7, let me zoom in a little bit, 3x to the power of 7 plus 9x cubed, subtract x plus 4, and I don't know what it actually looks like. I can tell that based on my highest degree of 7, if I do 7 subtract 1, that means I'm going to have 6 turning points. So pretty straightforward on that. Okay, with those turning points, this is just a max number of turns. It doesn't necessarily mean you'll have exactly that many turns. It just says you could have up to that many. So on this equation, if I actually graphed it, I might not have exactly 6. That's the maximum I could have. So I could have 5 or 4 or 3 or 2. So 6 or less. So the maximum number of turning points does not necessarily indicate the actual number of turning points of a function, just that it can have no more than that number. So some functions may have fewer turning points than the number calculated. So just kind of keep that in mind, and we'll kind of get to that in a second of why that happens. So a turning point can also correspond to what we call a local maximum or a local minimum. So a local max or min are just going to be either the highest value or the lowest value in a specific area. So if I go and draw this little shape again, let's say this is my graph. We would call this a local maximum because it's taller than the points around it. It's not the absolute max because this graph keeps going up for forever, so I'm not actually going to have a highest point, but this point based on the ones around it is taller or more of a maximum, so this would be a local max. And then on the flip side, we would say this one would be a local min since it's lower than the points around it. Again, it's not the absolute minimum because these points are going to keep going down, down, down for forever. So there's lower points than this one, but compared to the points around it, it's lower. So we call it a local minimum. And you'll sometimes hear it also as a relative max or min. So local max or min or relative max or min. Okay, another characteristic we like to talk about are the roots. You've probably heard this term in math before. But roots of a polynomial function, they are your x-intercepts. So that's just kind of another name for it. These are where you're crossing your x-axis. So a lot of you already know how to find x-intercepts or roots, but just based off of your function, you can tell how many roots that you could have. And that's going to just be the highest degree of your polynomial. So that's going to be the maximum number of roots. Again, when it says the maximum number, that doesn't mean it will be exactly that number. So say you have a max number of 5 roots, that means you could have 5 or less roots. So a polynomial function with a degree of 10 could have up to 10 roots. But it could also have 0 to 9 roots depending on the specific equation. So again, that's just a max number. You can't go over 10, but it could be anything less than 10. So recall that real numbers include all rational and irrational numbers, but they do not include imaginary and complex. So we're not going to be dealing with imaginary or complex roots right now, just real ones. So let's look at some examples using kind of these different terms you're learning. On this first example, it says determine the end behavior, the max number of turning points, and the max number of real roots of this function. So it says 6x to the power of 5 minus 3x to the power of 4 plus 2x plus 7. I know that's kind of fuzzy the way it printed, but I think it's power 5, yeah. So let's just go one at a time. So let's do our end behavior first. I'm just going to abbreviate. So for our end behavior, remember when we look at that, you're going to find your leading term, which is the 6x to the power of 5. So this is telling us about our end behavior. So first I look and see my exponent. This exponent is a 5. So it has an odd exponent, and it has, for the coefficient, we don't really care about the value, just if it's positive or negative. So this is a positive coefficient. So for a positive coefficient and an odd exponent, what does that mean? So remember, odd exponents are going to go in opposite directions. So I think of O for odd and O for opposite. That kind of helps me to remember that. And then a positive coefficient means it's going to have a positive slope. So going from left to right, it's going to go down to the left, and then it might do some weird things here in the middle, but then it's going to end up to the right. So we just are looking at those two ending points. So we're going to say it's going down to the left and then up to the right. And that's how we could write our end behavior. So again, the odd exponent is saying they're going in opposite directions, and then because it is a positive coefficient, it's going to kind of have that positive slope overall. So from left to right, it's going up. Let's look at the turning points now. So for our turns, you're still going to be looking at that highest degree, but the trick here to know how many turns you have is you just subtract 1. So I'm going to do 5 subtract 1, which is 4. So there's up to 4 turns. Remember, that's just a max number, so there really could be 3 or 2 or 1 or 0 turns. Okay, and then the next one asked is the number of roots. So the roots, this is the easiest one, is just going to match whatever your highest degree is. So there's up to a maximum of 5 roots. And so then those would be your other two answers. Okay. Let's move on to another example. So this one, it gives us the graph, and it says to describe the end behavior of the given graph. So hopefully you guys can kind of see that. It's going in this kind of, looks almost like little mountains. Determine whether the graph represents an even or an odd degree function, and then the number of real roots. So if we look at our ends, this end's going down, and this end is going down. So our ends are going in the same direction. If they're going in the same direction, that means it has to be an even degree. Remember, odd degrees go in opposite directions, even degrees go in the same direction. So it has to be an even degree, and then they also want to know the number of real roots. Remember, roots are just another name for intercepts. So if this is my x-axis along here, we have an intercept going here 1, 2, 3, 4 times it crosses. So there are 4 roots. So I think that's all I asked, right? Just whether it was even or odd degree. We decided it's even, and then how many roots it has. So it had 4. It crosses 4 times. Okay. On this next question, it says to use a graphing calculator to graph this equation and then summarize the end behavior and the turning points. If you have a graphing calculator, great. If you don't have one, check with your home school, your high school. A lot of the schools are checking out calculators, so you might be able to just borrow one from your library. You can also get one off of like KSL or off of Facebook Marketplace. I see people selling them for pretty cheap, but you do want one that has graphing capability. So we use a TI-84 Plus. This is a really good calculator. You'll be able to use it all through school. So if you don't have one, I would recommend getting one. But if you don't have one, another option that you can be doing from home is either get the Desmos app on your phone. So it's spelled like that, Desmos, or they have a website. So you can do the app or go to desmos.com. And then you can just type in your graph on your computer that way. But just a heads up, if you have the app, I'm not going to let you use your phones on the tests. So you do need to have something as a backup, either a calculator you can borrow from a friend, something like that. But you can use that for now. So let's graph this this function. So you're going to go into your y equals, let me clear all that stuff, and you're just going to type in your equation. So a negative x to the power of 4 plus 3x squared, plus 4. And then you're going to hit the graph button. And hopefully your window is in a pretty normal spot like this where it's a pretty standard setting. If yours isn't, you can go into your window, and I usually just go from -10 to 10 for my x minimum and my x maximum. And then for my y min and my y max, I just go from -10 to 10. And what that means is you're going from -10 to +10 here, and from -10 up to +10 on your y-axis. But here's our graph. Looks kind of like a M shape. So they want us to summarize the end behavior and the turning points of the function. So if we look at our ends, this end to the left is going down, and this end to the right is going down. So we're just going to say for our end behavior, we're going down to the left, and you're going down to the right. Okay, and then for our turning points, you're literally just counting how many turns you have. So where you're switching directions. So from here I'm going up to down, so there's one turn. Here I'm going from down to up, so here's a second turn. And then from up to down, there's 3 turns. And I did give a little spot to graph it. I'm just gonna really quickly do a rough sketch. But we had something like this. And then on this next question, it's kind of going backwards from what we just did. So they want us to come up with the rough sketch of the graph, and then they give us the information. So they're telling us it's a 6th degree polynomial function, and it has a positive leading coefficient. So that is our clue. It's a 6th degree and a positive coefficient. So based on what we know for end behavior, if our degree is an even number, which 6 is even, then we know that it has to go either up, up, it goes in the same direction, or it has to go down, down. So now to determine if it goes up or down, that's based off of its coefficient. So since it's positive, we know it's going to go up, up. So our end behavior is going up to the left and up to the right. And then we also can determine kind of how many how many turns we're going to have on here. If my highest degree is 6, then for my turns, it's going to be 1 less than that. So we would have about 5 turns. So if we come through here, and then we could also do our roots. Our roots just match our degree of 6. So one possible sketch of this graph, here's my axis, my x-axis and my y-axis. We know that it has to be ending going up and up. So it has to connect to these going up and up. And then we know it has to have 5 turns, and it's going to cross this 6 times. So I'm going to go 1 turn, 2, 3, 4, 5 turns, and then I need to connect to the top. And then that should just kind of naturally give you 6 roots. I have 1, 2, 3, 4, 5, 6. So if I actually graphed this graph, I probably wouldn't match that exactly. I don't actually know the exact function though, so that's kind of just all I can do based off of the information they gave us. But because it is a 6th degree with a positive coefficient, it has to end going up on both sides, and it has to have maybe 5 turns with 6 roots. Okay. And then I think we're just going to end there for today. The multiplicity is what we're going to talk about next time. But the multiplicity and actually graphing by hand kind of takes a minute. So we'll just split this into 2 days, I'm thinking, so that it's not too long of a video lesson for you. So hold tight, we'll go over multiplicity next time. So just go ahead and get started on your homework, and then we will finish this up next time. So if you guys have any questions, as always, feel free to reach out to me, send me an email. I am here to help. Hope you have a great day. See ya.